now that we've got our heads around voltage, current and resistance, then we've got the basics for operating electric circuits. And the reason we operate electric circuits is to do things with them. So we want to transfer electrical energy into something else. So for instance, if I'm powering my kettle, I want to take that electrical energy and transfer it into heat to heat up my water. So what we want to be able to do is calculate how much energy we're getting out per second. And that's going to be the power of the circuit. So first thing I'd like you to do is just have a little think about how you might calculate the work done by an electrical circuit. And I just want you to have a little think about how you might get there for yourself. This is going to be a challenge, particularly for the people who are looking for those higher grades. So you've got V, you've got I, you've got T. How would combining those get you the amount of work done by an electrical circuit? Give you a little second. You can pause if you want and have a little play. So what you're going to want to do is start with voltage, because we know that voltage is equal to the work done per unit charge. So I've got work in there, and now I've got voltage and I've got charge. However, I'm not allowed to use charge in this because I'm told I can only use V, I and T. So I need to get rid of charge and get current and time. Well, that's easy because Q equals IT. So I can just plug those in. And if I do that, I'll come out with work equals current times voltage times time. So my work is measured in joules, my current is in amps, my voltage is in volts, my time is in seconds. So that's how I'd calculate the amount of work done by an electrical circuit. I'd look at the component, I'd look at the current going through it, the voltage across it, and how long it's doing it for. So if I want to know its power then, what would I do? How would I get from work to power? Well, power is just work done per unit time. So in an electric circuit, that would be equal to current times voltage. Because work was current times voltage times time. You need to divide by time, which gets me power. So here my power is measured in watts, electric current is in amps, and my voltage is in volts. So that's one way to calculate power. But what if I don't know all those things about my circuit? What if I don't know both voltage and current? Maybe I do know about the resistance. So let's think about it. I know that resistance is at voltage divided by current. And if I rearrange that, that gives me voltage equals current times resistance. Now if I substitute that into P equals IV, I get power equals current squared times resistance. So now if I know the current and the resistance, I can calculate the power. What though if I know the voltage and the resistance? Well, I can do the same thing. So I go back to R equals V over I, rearrange for I, because that's the thing I want to get rid of, substitute that into P equals IV, and I get out P equals V squared over R. So now I actually have three equations for calculating power, and I can just select the one that's more useful based on what information I know about the circuit. Easy peasy. So one of the main upshots of knowing how much power you're using, or how much energy you're using, is because you have to pay for it. So once we know how to measure it, electricity companies start charging for it. How cruel of them. So when we think about paying electricity for the electricity that we use, we don't really think about it in terms of joules, because 1 joule is a tiny amount of energy. I mean, it's kind of the amount of energy to lift an apple 1 meter. That's nothing. Think about boiling a kettle. Boiling a kettle uses loads of energy, thousands and thousands of joules of energy. So the joule is not a useful unit. So instead, we pick a more useful unit. We use kilowatt hours. Now you need to know and be able to define a kilowatt hour. The easiest definition is that a kilowatt hour is the electrical energy used by a device of power 1 kilowatt in 1 hour. Or you can say it's equal to 3.6 megajoules. You can learn either one, but I think having the definition that explains it is probably a bit easier to get to because it comes from the name. 1 kilowatt device running for 1 hour. So often we have to calculate the cost, so it wouldn't be uncommon to be asked how much would it cost to run a device. The way you do that is you calculate the number of kilowatt hours you use by doing the number of kilowatts the device uses multiplied the number of hours it's active for. Note these are in no way SI units. you have to use kilowatts and you have to use hours. It's one of the few times I'll tell you not to just stick it in SI. So it's not watts and seconds, it's kilowatts and hours. Then to calculate the cost, you just do the number of kilowatt hours by the cost per kilowatt hour. At the moment it's around 14 pence per kilowatt hour, but they'll always give you that number. Okay, and that is it on electrical power. All pretty straightforward, hopefully mostly actually kind of familiar from GCSE. So that is it on this one. Remember, any questions, just ask me when you see me.